Welcome to the AI Growth Podcast, where we share real stories from business leaders using AI to grow faster and work smarter. Here's your host, Saad Memon.
Thank you so much, Dr. Charles. I'd like to welcome you to our AI Growth Podcast. Dr. Charles is actually the founder of Calculation Consulting. And Charles, could you give the audience a little bit of background, of an introduction about yourself and kind of get everybody acquainted with what you do?
Sure. I'm a doctor, I'm not a medical doctor. I did my PhD at Chicago in theoretical chemistry. You might know one of my more famous classmates who just won the Nobel Prize for AlphaFold. And he was in my PhD group. And then I did my postdoctoral work in theoretical biophysics, theoretical chemistry. I was an NSF fellow, one of two in the country, where I worked with a group with another fellow who claims to invent, and another one of my classmates, Jürgen Schmidhuber, who claims to have invented like everything else in AI. Like he's sort of famous for having invented transformers before transformers were invented and things like this. So I've been doing AI for a very, very long time. When I graduated and did my postdoc, I came out to Silicon Valley to work with my graduate advisor's son-in-law on a startup. It wasn't Google, unfortunately, but we were working on sort of machine learning, trying to implement machine learning for companies. And since then, I just realized, there's a lot of power in implementing AI and machine learning for companies to help them make revenue. And I've been doing that basically as a freelance consultant. I have a small boutique consultancy here in San Francisco. I've been doing that for over 20 years and worked with companies like eBay, Walmart, GoDaddy. I worked at a company called Aardvark, which is acquired by Google, BlackRock, which is the big hedge fund. And I've done some consulting work also in the space of just general science, quantum computing, fission, nuclear power, things like this. So, and for the past few years or so, I've been focused on, as you said, Weight Watcher, which is an open source project, which is used to diagnose problems in deep neural networks.
Well, that's a lot. You've obviously been had a lot of experience with AI, machine learning, and things like that. One of the things I wanted to start right off with was nowadays a lot of companies, it's sort of AI and ML is a buzzword, right? Every company wants to be in it, or they want to use it to make their processes efficient and things like that. Since you've had almost 20 or 30 years of experience in AI and machine learning, what was it like in the 1990s, in the early sort of era of machine learning? Were companies still sort of looking ahead like they are now? Now every single company is kind of looking into AI and machine learning. What was the landscape like for
I would
companies
say
then?
Silicon Valley is 10 to 15 years ahead of the rest of the country. And when we first started doing it, it was, the internet was brand new. Of course, we knew about things like neural networks, but it was far too difficult to implement them. So we implemented simple things. It used to be you had to implement everything from scratch. So if you wanted to implement machine learning, you had to go and find some academic library and download it and integrate it into your code base. People were working in Java and Ruby, and you can't really do machine learning in Java and Ruby. So it was really a painful thing to do. Then, sort of later, the technology started to become commoditized. Python finally became the dominant. We were using Python in the 90s, but it became the dominant language. Ruby and the web engineering. Trying to do machine learning in the web engineering stack is very, very hard. Python is now enabled that tremendously. And so you have all sorts of libraries, scikit-learn, of course, being one of the most popular libraries that you could use for machine learning. That is now, it just didn't exist when I was doing, in the 90s. And of course, now, companies like Apple and Meta have poured hundreds of billions of dollars into developing AI infrastructure. So you can train your own neural networks at home. So, you might even think like 20 years ago, we would run a neural network. It would be some small piece of C code that we got from some academic library, at some university. And now, of course, it's produced by NVIDIA, and, it's in OpenAI, and, there's thousands of people working on the code base. So things have really evolved tremendously. It's really just exploded from what was once, a few hundred people. When I was doing it in the 90s, there may be 100 people in the world doing this stuff in industry, outside of the defense contractors or, heavy duty industry. There was no one in Silicon Valley really doing this. It was very, very boutique. And of course, now everybody's doing it. So everyone could take advantage of it.
It's become sort of the new buzzword trend, but I think there's a lot of value in AI and machine learning. Look at what ChatGPT is already doing, right? For everything, it's basically replaced Google in a lot of ways. Google search, everything is going through ChatGPT. And the more you feed the models and algorithms, the more it's getting better and better. Now with ChatGPT 5 along the way here, it's really exponentially improved on the way it's getting better with all of the information that we're feeding it, right? So one of the projects that you're currently working on is called Weight Watcher. And I kind of wanted you to tell our audience a little bit about how that works and what sort of efficiencies it's helping with companies, and kind of what inspired you to come up with Weight Watcher, and kind of tell the audience a little bit about that.
Well, here's the thing. I had a client many, many years ago, back when OpenAI was still a nonprofit, and they had, before they even released GPT, and they wanted to generate fake text, weight loss articles and Amazon reviews and things like this. And what I realized is that when you train these neural networks, there's no real way to determine whether the neural network is working or not. You just don't know. And, if you're generating 50,000, you have no idea whether the reviews are any good or not. You can't get a quality control on what's going on. And so I realized I needed some way to figure out if the neural network was working correctly or not. And I realized that, okay, this stuff's coming back. I should probably hit the books and, go back to doing research, the stuff I was doing in the 90s, and see if I can figure out how to solve this problem. And that's what we did. I worked out a general theory, sort of, informally with some faculty at Stanford and UC Berkeley, now mostly, on our own as an open source project. And the tool allows you to determine, if you train your own models, whether you did it correctly. And so it avoids having to do very expensive evaluations. It can detect problems early on, and it doesn't need access to any of the training data, which is really important in an enterprise environment because there are frequently all sorts of compliance restrictions around getting access to data, or it's just hard. You just don't know where it is. So, or people don't know what their models were trained on. So there was a tool I really invented for my consulting clients to help train when people want to train their own AI models, just to help them out a bit, to kind of figure out what's going on and make things work correctly. That was the basic impetus. And it's turned out to just be a very broad level research project. It turned out we discovered all sorts of things about why neural networks work, which is turned out to be very powerful.
Yeah, that makes sense. I know one of the companies that you were working with on was with Walmart, right? And sort of you had mentioned that a lot of companies have a lot of regulations, like they have to follow privacy, CCPA, GLBA, et cetera, right? So I guess whenever a company comes to you, right, and says, we want this solution, we want to see if this can implement our process and make it better. One of their concerns is their data that they don't want to share with vendors and things like that. So
They
that's
can't.
something, yeah,
Walmart,
yeah,
I built
yeah,
Walmart a solution, but I
yeah.
was not allowed to access the deployment system.
Yeah, right. So is that part of like your standard process? You let them know like we can work with around the CCPA regulations or your privacy
Well,
concerns, yeah,
in
for
their
their
case,
models.
yeah,
Yeah,
there are all sorts of things that go on. I mean, you just don't get access to the data, or they just don't even if you're allowed to have access, they don't know who to talk to get the access, right? Or there's something wrong. So there's all sorts of problems. So, data, I think in any enterprise, dealing with the data and getting the data right is very, very hard. And what's happened is that machine learning used to be really hard to do.
right.
So you spent a lot of time, and it wasn't surprising that it took a lot of time to deal with the data. Now the software is really easy to use. Anyone can use it. So it's a little surprising, but the data is still really hard to get to. So 95% of the work in any of these projects is just trying to help companies understand, what data do you really have? What do you need? What's good? What's bad? And how do you implement it? And then getting something into production. A lot of companies are not accustomed to putting machine learning products into production, and they don't know how to evaluate them. And that's very hard. It's very different than what they've done before. And it just takes a lot of work and education to get them to do that.
Yep. Okay. So like if a company says, okay, we can't give you access to this specific data. So do you use like dummy data? Do you use like similar data, like what they have, and kind of anonymize it? What sort of the or each company's sort
You
of
don't do
different?
anything.
Yeah.
I
Yeah.
mean, I can't stress how important it is. I mean, there's just
Yeah.
a lot of the work is spent just going, trying to talk. Look, what I tell people when they start projects is that the more stakeholders you have, the harder it's going to be to get the project done. And the problem with many machine learning projects is that people want to collect data from all sorts of places and bring it all together into the machine learning system. Well, you might be touching 5 different stakeholders. So it might take you a year to get the data because you're just trying to figure out what's there. And while you're trying to collect the data, teams are updating their databases, they're updating their APIs, Google Analytics is changing. So while you're trying to collect the data you need, the rest of the company is moving on. And you might find out by the time you build the product that all the data pipelines have changed.
Yeah.
So it's a real problem trying, and you have to understand sort of upfront what you're getting into. I saw a lot of news coming out saying that 95% of all generative AI projects are failing. And you see the same thing in data science. 80, 90% of all data science projects fail. And it fails because, people just aren't ready for what they're getting into. And you find out that it's not hard software wise. Like writing the software isn't hard anymore, but getting all the things organized around the software still very, very hard.
Yeah. And then one of the things that you had mentioned on one of your interviews was that a lot of these companies want like real life results, real world results, practical solutions, things like that, instead of kind of theory and sort of they want hard solutions and deliverables, right? Especially on any projects with the budget. So what sort of value proposition or what sort of deliverables do you give companies, or is it like sort of a different model, or what do you?
I mean, in the end, what happens is typically there's a project manager who wants to push an idea forward, and he maybe has 3 months to be successful. Right? He has a quarter. And if he can't prove within 1 quarter that the project's successful, they'll kill it. They'll cut the budget in half. They'll kill it. They'll do this kind of stuff. So you have to be very judicious about what projects you choose to do and which ones you choose not to do, because you can end up on a project where you just can't make progress because the data's not there. So what happens is sometimes you come into a project and you might get 30% revenue in a month. I've had a project 30% revenue a month. I had a project with 500% increase in revenue, right? Because the data was there, it was lined up, and we got lucky. There are other cases you come in, you work for 9 months, and there's just nothing there. Or like in one case, you get the project rolling and it comes up, and then you want to put it into another system. And this happened with Walmart. We had the project running great in like electronics, and then we tried to put it into the grocery. That's a completely different system. So the electronic stuff worked great, but the grocery, there was a glitch in the grocery data collection pipeline and it just didn't work. There's no way to fix it. And it was and just those things happen. Like you don't even know the glitch is there. Part of the problem with data science is that people they always want to take data from somewhere else. They're collecting it for some product to do, they're collecting it for search, or they're collecting it for billing, or they're collecting it for something insurance. And then they want to use it in some other model. And what I say is that there's a data quality mismatch. The quality of the data might be just fine for whatever it's doing in the company right now. But when you take that data, try to put it into a machine learning product, the machine learning needs a much higher level of quality. And that quality just isn't there. And you can't just clean the data. People think, just clean the data. Yeah, it doesn't work like that. The data is coming from somewhere else in the company, and there's some other, there's like a hole in the pipe that's causing it to leak. And you don't know where it is. You got to find it. And many, many times we've seen cases like this where the data works fine for, like, you have some dashboard, the data looks great on the dashboard. You try to take the data from the dashboard, put it in the machine learning algorithm. Yeah, it's not going to work. There's some weird little glitch you didn't know about in the dashboard that changed the data in some subtle way. And this happens all the time. And it's the curse of doing these projects. And so you have to really focus on what I tell people is you got to build end-to-end products. You can't just collect data, clean data, hand it off. You got to build something end to end so you can see everything, because you're going to collect the data, clean the data, hand it off to somebody, and they're like, I don't know what to do with this. You handed it off to me. If it's good, I'm good. If it's not, I can't do anything. I'm stuck. You handed me a lemon, right? And so you gotta test drive the car. You gotta go round trip. And that takes a lot of work, because that typically touches many stakeholders: data collection, engineering, deployments, testing, user experience. All of that goes into the pipeline. And it's usually something different than what the existing products are. So typically you need to have some executive buy-in so you can take the time to really do all the things you need to do. And that's just how it is, and sometimes you get lucky and sometimes you don't.
Yeah, that makes sense. So how do you, I guess, what is your process? Like, let's say a company comes to you and they said, okay, we're interested. Do you have some sort of like project checklist or due diligence checklist that you kind of look through,
Yeah,
or
there's no
before
way
you
to do
pursue
it.
something? Yeah.
There's no way to do it, because you have
Yeah.
to go in and look at the data.
Okay.
So
Yeah.
there's just nothing. I mean, I don't know what's there until I
Right.
look at it.
Yeah. It's like you got to pull the curtains back and then kind of look at it, right?
Well, you can make up all the process. Look, I have you can make up a process and give them a sheet and do all this, and they feel good
Yeah.
about it. They're willing to buy it. But at
Yeah.
the end of the day, you have to do it. You have
Yeah.
to build the product and see what happens. I can't look at the data and say, oh, it's good or bad. No, you have to actually commit to doing something. Like, you have to say, we want to make this work, and we're going to commit to doing 6 months, 9 months, 3 months, whatever it is, we're going to commit to figuring out what's going on. And then this is even big companies. Like my first project at eBay, they had 5 other consultants, maybe 4 other consultants they brought in. They couldn't get their email classification system working. They just couldn't, and they had different key, and they finally brought me in. I'm like number 5, so I'm the most expensive. And they finally said, we got to get this working. We're bleeding out $100 million a year in 40, 50, $100 million a year maintaining customers. eBay is the size of a small country.
Yeah.
So you have to fix it. So you have to actually be, and we spent 3 months just finding the bug. That's all we did for 3 months, is I just sit in project management, talking to different people, trying to figure out where is the bug in the data pipeline that's causing the classifier to fail. And you have data coming from all over the country, because you have people in India doing the support.
Yeah.
Some guy in Germany is doing this. Another guy in Texas is doing that. And they all have to coordinate. And, as the data gets passed around, something got tweaked.
Yeah.
And we found it, but
Yeah.
it took 3 months just to find that tweak. So this is normal, and it's part of the process, and you have to be ready for that.
Yeah. So kind of like in this eBay example, it sounds like the first 4 or 5 consultant companies, they just kind of came in and did whatever. But then you took the time to find the bug and then move that step forward and solving their email problem.
Well,
And yeah,
the way
exactly.
the manager, the guy who brought me in was ex-US Special Forces.
Okay.
So he said to me, I want you to find out who's lying to me so I can crack their head open. Okay. We're going to go talk to everybody, and we're going to go talk to all the people and look at all the data and look at all the pipelines and figure out why things aren't working.
Yeah.
Right. Because his job was on the line.
Right.
Right.
Yeah.
So he had to crack it. And, he was a serious dude. And so, you see the same thing. It's just, data projects are hard.
Right.
And it's hard because people they're not set up for it. They're just
Yeah.
not set up for it. It's hard. But, we can, there are other cases. Like I had a client I work with, Swoop.
Yeah.
Within 2 weeks, we had revenue up 11%. They'd worked for a year trying to build a system, couldn't get it to work, brought a Harvard mathematician. I came in and worked with the founder, who was a programmer. Within 2 weeks, we had revenue up 11%. Within a month, we had revenue up 30%. Revenue,
Wow.
direct revenue, right?
Yeah.
Because we implemented things correctly. So you have to, it helps, because typically you need someone who can cut through the fat in the organization
Yeah.
and get people to do what they need to do. And that's where, you have a CTO, or you have a founder, or you have a guy who's US Special Forces, guys who can do that, who can, go and crack. Now, there are other places like BlackRock. They're very well organized, right? There's no problem at BlackRock. Right? The data was there. There was a data guy. You work with him. He gives you the data, and we put models in production. That was no problem, right? That's just smooth as butter.
Yeah. It's like a straight path, straight road.
Yeah, they're trading orders. That's all they do all day is trades. And they know where their data is. They know how to get it. That was not a problem. There are other issues, but that was not for the data. So the other companies, they're very well organized. And if you're well organized and you've done similar things, you can do very well.
Yeah. So it's kind of like it almost seems like you're almost like a private investigator, detective. You pull out your magnifying glass. You got to
Yes.
cut through the fat and go through each different department and figure out who's hiding it, or maybe they're not hiding. They just don't know where it is. It's just disorders. Yeah.
Sometimes they're hiding it. Sometimes
Yeah.
they're hiding it, right?
Yeah.
Sometimes they do. And they do. I hate to say it. There's some people who are
Yeah.
dishonest.
Yeah.
But look, as a consultant, frequently you're like a doctor. You see a lot of sick patients, right? I don't see a lot of healthy patients, right? Because they don't come to you. If they already know what they're doing, they're not going to come to you, right?
Call you when
BlackRock
there's
is
a
different.
problem. Yeah. They call you on the problem.
Yeah, so that's why they come to you. If you have a problem, if everything's going well, you don't need me, I'm happy to help you. But, BlackRock was different because they were looking for algorithms to predict the market. So their problem was not a data issue. They just needed like some fresh ideas, because I have a quant physics background. So they wanted fresh ideas in quantum physics, because they hadn't thought of, the thing about trading in the markets is you need fresh ideas all the time,
Yeah.
because, things get stale.
Yep.
So that was a different operation. That was one, you're just working with, you're trying to bring the machine learning and AI technology into the company. They want to understand how to use it, They're pretty good at everything else. They've just never done this specific thing. And if they've never done this specific thing, then you work with guys who are experts in data or finance and, genius level quants and finance professors. And, that's a different kind of thing, right? You're trying to bring the technology in. You already have a really good technology company. You just don't do this specific thing. And I think with Gen AI, there's a lot of that where there are probably a lot of companies who are very good at what they do,
Yep.
but they've never done Gen AI. Right, so
Yeah.
they want to stay, and that's totally new. That's a totally new thing. So there's that as well. So that's so it's just a matter of how do you have to start with where someone is, right?
Yeah.
You start where they are and you try to help them out as best you can.
Yeah, with Gen AI, it's like a lot of these new concept in AI and machine learning. A lot of the companies don't even know that that's an option. So you kind of have to go in and sort of educate them, educate their team, help them understand what the value proposition is, and go from there. Because they're coming to you with to offer a solution, and that's where your job comes in, and you can explain it to them. Basically, sounds
Well,
like.
you have to build something,
Yeah.
right? You come in to build something and you try to work with their team. You try to work with their team to build it. That's what you're trying to do. And you try to explain to them what's going on. And I think the biggest challenge with machine learning is that it used to be I would work with co-founders and CTOs and, people who are managers. Now you're getting many more people wanting to get into the space. And a lot of the problem is that the project managers don't have experience. So, you'll work for the client, you're going to have to work with the PM. You're not working with the CTO, right? I've worked with like the super wealthy. I've worked with VCs. I've worked with portfolio managers, but I've also worked with, PMs at small companies. Like GoDaddy is an example where you had to work with the PM. Well, they have to fit within whatever their PM has requirements because there's a certain process the way the company works. They have to fill out an SOW. They have to report. They have reporting requirements. They have to manage things. So you have to work with that person. And it's hard for them because they've never done it before. They don't know anything about machine learning. So for them, it's not software. They don't understand. Like I had one client once, Glam Media. Now, Glam Media, I work with the founder, but I was, the founder had said, you got to work with the PM to try to get your product in production. Okay. So he says, well, where are the unit tests? I go, what are you talking about unit tests? He goes, you've been working on this for 3 months. I go, what do you think I've been doing? I've been trying to crack this problem that you want me to crack, which is how do I make this prediction? How do I build this thing for you? I'm not writing software. I'm trying to solve this problem so that you can implement the software. And a lot of times people misunderstand that doing the machine learning data science part is not the software engineering part. Those are two different things, and they're overlapping. It work together, but frequently you're trying to solve. In this case, they were trying to build a classifier to classify ingredients in recipes. And it's like they couldn't get it to work. I go, I have to figure out how to make it work. I'm not writing production code. That's later. That's after I figured out. I've had other clients say, we want to hire you to do this machine learning stuff. And they're like, well, why don't you know how to do Ruby? I go, I'm not a Ruby web engineer. I'm a machine learning guy. I don't know Ruby. Like, what do you want me to do here? And so they misunderstand, like they don't understand the process it takes to solve a problem. So frequently you have this challenge that you work with engineering teams or PMs, and they're used to assigning a project and then you just do the project and you implement it. And frequently you're trying to figure out what's wrong. And so it's not always software driven. And that's confusing a lot to some people that the projects are not as software driven as they want them to be. Even when you try to be that, you still have, you're trying to solve problems. You're not writing code. You're doing something else. And that can be challenging. And that's why you see now the advent of data science teams. Like their data science teams, engineering teams. That didn't exist before. 20 years ago, there were no data science teams 20 years ago.
Yeah.
It was a guy I worked with at eBay, I think, who coined the term data science. But back then, there were science. So it's changed, and I think that's part of the challenge as well. Frequently, your people they don't even know what to expect. They've never done it before. They don't know what to expect, and it's not like what they've seen before, and they get a little frustrated because they're not they even if they have visibility into what you're doing, they don't understand it. So you give them visibility, but they want operational control, and it doesn't work, right?
Yeah.
Because you're not. So this is a challenge with a lot of companies, and especially with the PMs. The PMs want to. They're used to assigning projects and tasks, and
Yeah.
that's not what's going on here. So
Right.
that can be challenging.
Yeah, it's kind of like they have their own box and they have to fit it into those requirements, deliverables, project timelines, etc. One
Right,
of the
right.
things, yeah,
Absolutely.
one of the things that a lot of companies are sort of going towards is the model of chatbots, things like that. For example, Walmart, right? Instead of you calling their support team, first what they do is they try to get you to go through the chatbot. Everything is through the AI. So can you kind of talk about a little bit about how maybe your technology has helped develop AI ML chatbots and things like that for support? A lot of those companies are looking to save money on the client support, customer support. Can you talk about a little bit about chatbots and what the trend is
Well,
towards that?
I think that it's the challenge with chatbots today is that people want to use Gen AI as the chatbot. And the problem is that there's no way to guarantee that the result you're getting is correct. And so, I invented this technology to help people who are training their own models. So people doing recommendation systems, people doing ad tech, people doing medical diagnosis, people doing finance, people doing chatbots. Aardvark was a chatbot. Right? We
Yeah,
trained a chatbot to do things. But if
yeah,
you're not training your own models, if
yeah,
you're just using off the shelf Gen AI, you gotta, you get what you get. It's
right.
gonna do what it does, and you're stuck with trying to figure out what the prompts are, and I think that, a lot of the challenge is you're trying where I'm working on is for people who are trying to train a model to do something very specific. You have maybe a recommender with a RAG system, and then you have a little model right on top of it that's trying to learn from the user interaction. And that's where the Weight Watcher technology comes in. Generally speaking, though, in dealing with chatbots, you're dealing with the fact that, you've got to try to figure out some way to validate that the result is correct, that you're getting out what you want. And that's usually requires some custom engineering or something to is this really what we think it is? Like, is the result actually the right result? Can you match the result to something in, a database? Or did you build a RAG system and is the RAG system working correctly? People think RAG is like this magic box, but it's not. It's not. You have to check it to see, like, how do you build check systems to see whether RAG is actually delivering, it could pull out anything, it's not a magic box where you just stuff stuff in. And I think that's, working with clients, sometimes you have to come up with custom solutions to figure out what they're doing because these solutions don't exist yet in the market. So an example would be there are cases where you might have 5 different chat windows. You submit the request to the LLM 5 different ways, you get 5 different results, and then you compare the results to see how much they deviate. And then over time, because usually the chatbot has some context that you're keeping over time, and not just a single instance, but there's like a thread where you go through. So it's very much you're trying to figure out the intent of what the user is talking about, and you're trying to reverse that intent by looking at the responses, and you wanna make sure that the LLM doesn't go way off here. So you have 5, and you might wanna pick what is the best response automatically, making sure that it doesn't diverge widely from what was done before. So that would be the kind of solution you would give in that. And I've helped design some systems like that where, you're just trying to maintain the context of the user. Because what happens is people don't really explain what they want. You have to and as you're trying to infer what they want, you have to make sure you don't go off the rails.
Right, right, exactly. And with ChatGPT, the consumer model, sometimes what it does is it gives you two different answers, right? And it says pick the best one, and then it feeds into itself and tries to make the algorithm better. One of the topics that you kind of mentioned that's very fascinating to me is grokking, right? A lot of the chatbots, what they do is they hallucinate data, right? It's going to be a lot of incorrect instructions and things like that where you think a lot of people just depend on some of those answers and they just think everything that the chat gpt tells you is 100% correct. A lot of that data is hallucinated or they're just kind of regurgitating information and displaying it back to the person using it, right? So can you talk a little bit about that hallucination of data, grokking, and kind of explain that concept to the audience?
Well, what happens, what's happening is that, the AI is going to just give you answers that it thinks sound right. So think of the AI more like as a child, like your 5 or 6 year old or your 4 year old niece who will, they'll talk to you and they'll just make up stories that sound good and they're looking for attention from you or they're looking for feedback. That's what it is. It's like a child who just knows everything. It's like a child with a really, really good memory that has memorized tons of stuff, but doesn't really have a functional understanding of what it's responding with. I think people want these things. They think that AI means that it's Einstein or Data from Star Trek. It's your 3 year old niece, right? It's your 3-year-old niece who happens to have a photographic memory and has just been absorbing huge. I mean, I have a nephew and he just absorbed huge amounts of information. He was watching Paw Patrol, and they have, the construction guys, Rumble and Paw Patrol. So he became obsessed with construction. Now, it turns out his dad has a photographic memory. So the kid has an incredible memory. So he would just read books and books and books and books and books on construction. We didn't know what he's reading. He's like 5 years old, So you'd ask him questions and he'd talk about it, and he could sort of regurgitate what he heard. He can do basic pattern matching and he has some basic logic, but he's still a child. He still makes stuff up. He still says stuff to you that doesn't make any sense. He still gets confused over things that are, that he doesn't really understand aren't real. It's the same thing, You're not dealing with an experienced it only seems like it's an experienced professional because it's talking about all these complex topics.
Yeah,
But it's really just a small child who is a bit of a prodigy in terms of his memory and just memorizes lots of stuff.
exactly. Kind of like a talking parrot, like a talking parrot. You
Well,
tell it
yeah, I mean,
something, spit it back out to you almost.
parrots are smart.
Yeah,
Parrots, no one they understand some of what they're saying. They don't understand English, but they understand, like, they can curse at you and they know how you respond. Like, they'll say strings of words and they watch how you respond and they learn how to do stuff. They're not stupid. They're not human, right? I mean, so that's the same thing. Like, it has some basic reasoning ability, but it's not, it's not a PhD level doc. It's not a brain surgeon. It just sounds like one. And that's the problem. People think that, because it sounds good, that it must be right. And it's more of a BS artist, right?
yeah,
And you have to be very careful because it will sound something it will say things that seem really correct, and it turns out to be completely wrong. And it's very subtle. And they're very subtle, and you have to pay attention very closely to what's going on because it does that. And that's just how the technology works. You're not going to get around that. You're not going to get around that with, it just you're not going to get around it using RAG or using data. You have to really work hard to figure out what this thing is doing. You have to be very careful with it
yeah.
because it will make stuff up.
Yeah. Would you say like there's so many different AI softwares out on the market? You got Claude, you got ChatGPT, DeepSeek, et cetera, right? Grok. Would you say, is there any one sort of specific company or model that's sort of getting ahead of this or doing this better than anybody else? This sort of hallucination of data? Or do you think they're all pretty much the same and it's sort of the same
No,
technology?
they're all the same. No, I don't believe anyone saying they can detect hallucination. Look, what does everybody do, right? This is how they do it. I have a model.
Yep.
And I have another model which detects hallucinations, and it's trained to detect hallucinations. That's what they do. That's what everybody does, right? And the model is somehow trained to know it. So that's what you do. And what you do is you just use multiple models together, and that's how you avoid it, right? And so the multiple models, or you ask the model the same question 5 times and see what it says. But there's no magic box to detecting hallucinations. And in
Yeah.
terms of how the models work, I mean, what the different companies are focusing on different things. So OpenAI, its big thing is memory. So when you work with OpenAI, it has a memory and it remembers what you've told it in the past. When you work with Google Gemini, it has a massive context window. So you can give it huge contexts. When you work with Claude, it's really, really good at coding. Right? It's good at coding. And the OpenAI guys are now trying to get good. Like GPT-5 is a big advance in coding. They're trying to catch up to Claude. And if you look at OpenAI Codex now integrates with Windsurf and Cursor, and it's getting more sophisticated. They're trying to focus on that. Beyond that, I mean, those are the 3 big ones, right? The rest of them, I mean, you look at some models are more sensitive to variations in the input than others. Well, the llama models tend to be less sensitive to variations in their input. Right. And one of the things we discovered with Weight Watcher is that the better the model seems to perform, the more it hallucinates.
Really?
Yeah.
Okay.
It's better
Interesting.
at hallucinating. It's better at tricking you. So
Yeah.
this is something that's very curious, that the models that don't hallucinate as much are also more brittle. They're not as clever. They're not as creative. So be very careful. Now, OpenAI they're getting better at trying to reduce hallucinations. There's some basic theoretical understanding of it, but I wouldn't say that there's any deep theoretical understanding. It's just they're getting better at the training processes are getting better. They're better at training. Reinforcement learning is getting better. DeepSeek has sort of pushed everybody to work a lot harder to figure out how to train their models, and the data sets are getting better. So what happens is, a lot of these models are just trained on incoherent data, and that causes problems. So the incoherence in the data, if you train a model on every piece of software on GitHub, you get all the bad code. So you get bad code as good as good code, and it doesn't know the difference. That's what's going on.
Yeah.
And so they're just trying to get better at analyzing code and cleaning up the data sets and things like that. And the big companies are getting better and better at this. But it's to say they have the same problem that any company has. The data really matters. If you get the data wrong, you got a problem.
Yeah. Yeah. One of the things that you kind of touched previously was that there is this sort of HTSR, heavy tail self regulation, right? So, can you kind of tell a little bit about how there's a fingerprint left on the data model and explain that concept to our audience in
Right.
very basic, simple
Right.
terms?
So it turns out when you train, so people don't understand how to train models. So they train these models, and the big guys, they have a lot of money, right? But the theory of training models is not very well advanced. So what happens is if you're trying to train or fine tune your own model, if you're fine tuning your own model, you're training one from scratch, it turns out that we've discovered there are certain scientific principles which govern how the layers converge. And you could think of the model as sort of like a cake, a layered cake, lots and lots of layers. And as you train it, you're baking a cake. Well, what happens is when you bake a cake, you got to get the temperature right. Or maybe in Texas, uh you're cooking a brisket, right? And when you cook a brisket, right, you have to get the temperature just right so that the fat will melt into the meat. And if the temperature is too hot, you cook the meat, but it kind of gets burned. And if you don't cook it long enough, then the fat really doesn't melt in and you don't get that really tremendous Texas, barbecue flavor. And it's the same idea that when you're training a model, you're basically smoking it. You're baking a cake. You're cooking a brisket. And as you're doing that, you have to the layers. You think of the model as like the different layers. You've got the meat, you've got the fat, you've got the collagen, you've got the seasoning on the outside. It all has to cook at the right temperature in the right way with the right airflow. Otherwise, it doesn't come out right. It's the exact same thing with these models. And what happens is certain layers, the models exist, they're like layered cakes with lots and lots of layers, maybe 100 layers. And the layers don't converge. So, like, the inside is not quite cooked and the outside is too crisp. That's what's going on. And Weight Watcher watches the weight. So, as you're training, it will watch it and it will help you figure out how to train it in a way. It's like a temperature thermometer. It's like a thermometer, or an x ray machine for the model. That's
Yeah.
what's going on. That's what
Right.
it does.
Yeah. So it's essentially trying to detect which data is good data and which is not so good data and trying to correlate that between what is useful for the model.
Well, it doesn't need to look at the data. It
Yeah.
just looks at the weights. By
Okay.
just looking at the weights of the model,
Yeah.
you can figure out whether the model is being trained correctly or not. That's the key, is that you're just looking at the weights. And that's it's very surprising to people that you can do this, that the weights contain all the information. Well, they don't contain all the information, but they contain enough information that you can figure out you can get a broad level idea of what's going on.
Yeah.
And
Yeah.
that's the magic of the tool.
Yep. Yeah. So it's essentially making sure that like the right thing is weighted correctly. It's not over or underweighted and making sure that that is what the model is using essentially.
Right. That's right. Yeah, making sure that so like in Grokking, what happens is the models tend to people think the model memorizes its data. But there are different ways of memorizing. You can memorize the data and not really and you can memorize the data without being able to predict anything. But that's kind of like an ethereal memorization, a transient memorization where, it's different than when you have this sort of overfitting where you overfit the data, where now you kind of get caught in a loop and you just keep making the same predictions over and over and over. So there are cases where the models will just make random predictions and they're just kind of noisy and they do random things. And then there are cases where you kind of get caught in a loop and they just repeat the same thing, or they make the same mistakes over and over. And that's sort of what the tool can detect, which kind of bad memorization the model is doing. And layer by layer. That's what it's for. So it's really for specialists who are trying to train their own models. Or maybe, you're training a model and you want to maybe you're training a model for like a robot and you want to give that model to the people making robots. And you want them to have some confidence that, the model's not that doesn't have any weird problems. So Weight Watchers kind of consumer reports tool that lets you tell your customers, oh, I built this model for you. Let's run it through the tool. Now, you can have some confidence that the model is going to work correctly without having to do lots and lots of expensive evaluations.
Kind of like a grading system. Like, okay, yeah, we give your
Grading system, yes.
A or B or C, kind of like how good it is, and giving it a general score, sort of.
Yes.
Yes, okay, that makes
That's what
sense.
it's doing. And
Yeah,
that's the idea. And so we work with people who are training models for other people, maybe for robotics, maybe for medicine, and they want to just have some confidence that, they want to look for problems early. So you catch the problem early on so you can go back and review your training process to make sure there wasn't some weird problem. That's what's going on. So like an early warning system.
early warning, kind of like before you have like some sort of severe weather coming up. Okay, since you've been in this industry for so long, right, what is sort of the biggest shift in AI? What would you say is the biggest overall shift
Well,
in
no,
the?
I mean, I think the development of these reasoning models is the biggest. The idea that, you have these models that now there are these general purpose models that can solve problems just by talking to them. I mean, that did not exist. Even 10 years ago, no one thought that was going to happen. That's a huge advance. And it's both a huge scientific advance, and it's also created this tremendous desire to have AI that we think, well, we can create, artificial general intelligence. At the same time, we have no idea what it is. Right. So we're trying to create something. We really don't know what it is. And for me, it's a lot like the steam engine. When we built the steam engine, people used to race the steam engine on steamboats or
Okay.
NASCAR. Yeah, they'd
Yeah.
race the engine, and then eventually once in a while they'd race the two boats and one boat
Yeah.
would blow up.
Yeah.
They raced it so hard. It
It
just
was
blow
like the
up.
hot rod of the back in the day, like the hot rod.
Yes, yes, and that they did, and it's like they didn't understand steam engines. There was no thermodynamics, so they
Yeah.
just built these things. They almost, I mean, almost all of the Boston almost burned down because the steam boiler blew up. So we didn't have thermodynamics. We didn't understand how to control these systems, and that's where we are now. Like we have this amazing technology, can do all these things, but we don't really understand how to control the technology. So we're at that early stage. And I'm trying to come up with a control system, a thermodynamics for AI, so that when you build these systems, you'll have some confidence that, it's not going to blow up.
Yeah. Makes sense. The next thing that I wanted to kind of ask you is, what do you think most companies are getting wrong about AI right now? Like, every company wants AI to do everything and make all of their processes like very easy and simple, right? But what would you say most companies are doing wrong trying to utilize AI? And what would you say is the biggest way for them to actually use it correctly? What would be your advice to companies looking to get into AI and using it to make their processes efficient? And what is the right way they should be looking at it from a wider company perspective?
Well, I think you should be looking at the how do you have to realize that the AI systems are difficult to control. So you don't want to put something into a process where having an error in the process can shut the company down. So there are cases like if I'm running an ad tech company, like I'm running a search engine, and I show an ad to somebody and they don't click on the ad, it's not a big deal. I got other ads, right? It's not a big deal. We won't make a lot of money, but it's not going to kill us. But there are cases where if the AI makes a mistake and it destroys the company, well, then you don't want to put it in production that way. You got to so that's the challenge, is understanding how much tolerance do you have for failure, because these things fail. They fail a lot. They fail in unpredictable ways, and they fail in ways you can't detect. So you have to be willing to have, you have to be careful when you put them into a process to realize, what kind of quality control do I need? What kind of quality control do I need over the process? Does it have to be strictly perfect, or can we accept some errors? And that's essentially where we are.
Makes sense. And then looking at various different companies in different industries, like you have all these different companies that want to implement AI based on the different business lines, departments in each company. Currently, based on the AI technology, which department or which sort of task would you say that a company would have the most value in using AI right now, ML, and specifically part of a company across industries, right? Across different sector. So what would you say is the biggest return that they would get in what sort of business line or what sort of processes in a company?
Well, I
Yeah,
think the biggest are things like where I do think things like, having sophisticated chatbots that can provide advice, can help people get answers to questions, knowing that the answers might not be correct, saying, look, here's a possible suggestion. I think search. search systems, enterprise search, where people are trying to find information. Because sometimes you're finding information, you kind of, as long as you understand that the information you're looking for could be inaccurate.
Yep.
Certainly in analyzing documents and realizing I want to read some very complex document, try to understand it, realizing I'm still going to have to go back and do this is just the first pass. Even in things like legal review, where you're looking, okay, it's trying to highlight What AI is really good at is highlighting problems. So
Yeah.
you could see a problem that exists. Say, okay, I didn't find every problem, but if I find a problem, I save a lot of money. It's useful in things like, in anywhere you're trying to find anywhere where getting a good solution is saving you a lot of money, but if you don't solve the problem, you're going to lose the money anyway. So here's an example. We had an insurance company come to us and they said, we have problems identifying the correct customer. And sometimes people apply for credit and we don't give it to them. And then we get sued because we discriminated against them. And we did it because we misidentified who they were. Charles Martin's a very common name. When I was working at eBay, I had to take a week off because I got fired because they thought I was, a cocaine dealer in Florida.
Robbed a bank.
The guy had the same name, same birth date. I'm like, yeah, Charles Martin it's like one of the most popular. It's a French name. It's one of the most popular names in the country. So no, it's not me. You have to actually check the fingerprint. So I had to go back, check the fingerprint, and it wasn't me. Yeah, gee, thanks, guys. So and so like, in that case, like detecting that there was a problem would save the company hundreds of thousands of dollars in lawsuits. And if you don't detect it, it didn't matter because it was there anyway. It's stuff like that. You're plugging holes that are already there. That's an example where the AI makes a mistake and it doesn't matter because the hole's there anyway. So plugging big holes where you're bleeding out, if you're bleeding out, you can put a bandage on it. They save you a lot. And there are a lot of companies like this where there's bleeding out. The process is bleeding out somewhere and we've got to find a way to fix it. That also, this is a lot of stuff I see, right? Because I can, as a consultant, we're bleeding out, try to help us fix it. It's also a tremendous revenue generator. That's one where, I think trying to fix problems where you see these huge problems and you can make some dent in the problem, it's tremendous. And I would just and that's where I've seen the best success.
And then I would say one of the things that I think kind of we talked about, the data is hallucinating, regardless of whatever company it is, right? That's sort of part of it right now. What is something that right now is an unsolved problem for AI that you think over the next 3 to 5 years, it'll solve itself as companies get better with the data, training the models and things like that? What do you think is a current problem that will be solved in the next 3 to 5 years that's going to exponentially grow AI and the way it's being utilized by companies? Is there any sort of specific thing?
I almost hate to say it, I think a lot of companies you have to understand that Silicon Valley is waging an economic war on the rest of the country. Really the rest of the world. Their job is not just to give you a product that solves your problem.
Yeah.
They're looking to take over your entire industry.
Okay.
Like look at Uber.
Yep.
Do you have Uber in Texas? Is
Yep.
it legal, not legal?
Yeah, it's legal. Yep.
Right. So Uber is taking over taxis. Well,
Right.
now self-driving cars are coming after Uber. We
Right.
have self-driving cars in San Francisco. It's called Waymo.
Right.
And they're everywhere.
Okay.
So they're coming after Uber, right? And it's the same thing. The Silicon, you look at Amazon. Amazon's coming after Walmart, right? They're not trying to help Walmart be more
Yeah.
efficient. I tried to do that. They're
Yeah.
going to take everything. They're taking everything,
Yeah.
and that's the fear with AI. You look at Harvey. They're coming after the law firms. They're going to take everything. So I think what companies have to realize is that, do you actually have a moat? Right? Do you have a moat? If you don't have a moat, if you think you have a moat, is AI going to take your moat from you?
Right.
And what are you going to do to prevent that? Because they're coming after you. Either big company, you have little companies coming at you, 1,000 cuts, death by 1,000 cuts, and others like OpenAI that want to take over entire industries. And I think that, it's foolish to think that we have a moat and nobody can come after us. Yeah,
Right.
you'd be surprised.
Yeah.
There are always holes in your strategy. So you got to think hard about, what can we do to really solidify our moat? That's what I talk about, page, like something simple, like, look, why does Amazon kill people? They operated better margins.
Yeah.
So if you're bleeding out revenue, you got to
Yeah.
get your margins down because they're
Right.
coming for you. So that's where AI can help you. If you're having problems with, That kind of stuff. I mean, I think a lot of companies are not so much trying to innovate as much as they are trying to just maintain operations and improve them and make them more efficient. And there, it's very useful. The challenge is just making sure in the process of making your own process more efficient, you don't introduce problems that can kill you. You don't want a Cracker Barrel problem, right?
Right.
You know, they put it, that they put the new Cracker Barrel, the new Cracker Barrel sign up and the stock dropped. Like, what
Yeah.
is this? What did you
People
do?
are pushing back. They want the classic sign, right?
I love Cracker Barrel. I used to go there all
Yeah,
the time when I was living in the South.
exactly.
Of course. I mean, but that's the problem. You don't want to make a change that's going to kill you. So you have
Right.
to really think hard about, where can we implement this technology in our process? And
Yeah.
and another thing that even just basic data science and machine learning does is that it forces you to look across your organization. Many organizations are very compartmentalized. You do data science projects, whether it's data science, machine learning, AI, you're going to look at all these different departments. And they all have to work together. And you're going to find out that this compartmentalization, which is very efficient for doing what you're doing,
Yeah.
may actually be blocking you moving forward.
Yeah.
And you have to figure out how to get past that.
Yeah.
And that's part of the challenge.
Yeah.
So I'll leave you with that warm and fuzzy thought.
Yeah, that makes sense. And then for the companies, you have the advice. What about for the general Joe Blow, right? He's like, okay, AI is gonna take my job. There's this like big thing where people are thinking, oh, AI is gonna replace all the jobs and things like that. What would you say is your advice, like the normal person that's going by with their everyday life on how to work with AI and to kind of like calm down some of their concerns about AI replacing their jobs?
Well, I mean, I think that this has always been a concern with any of these products, that whenever you build a product that makes a job more efficient, there's somebody who
Yeah.
has to go because they're not efficient. And I think that the job nature of jobs are going to change where you have to start integrating AI into your workflows in such a way that you're more efficient. You can integrate it in, but it can make you less efficient because it gives you all sorts of wrong answers and you spend all your
Right.
days checking them. You're going to have to figure out how to integrate AI into your processes, into your workflow, so you become more efficient and more effective. And that's what you have to do. And I think it's true at the educational level
Yeah.
in particular that this is a big challenge because even the universities don't know how to teach. What should we be teaching? Because the kids are using AI for everything.
Yeah.
Are you really, you have to be very careful that if you're using AI that you're not turning your brain off.
Right.
Because what happens is that, the more you use AI, you sort of think it's doing something for you, and
Yep.
it turns out that it's just basically keeping you from thinking deeply about what you're supposed to be doing. And it has that sort of weird, effect that it makes you in a sense, it's like using a calculator for
Yeah.
everything. You get kinda dumber, right? So you gotta
Right.
be
Right.
careful that you don't get dumber when you're using it.
Yeah.
It's a very, it's a kind of thing where you have to use it to enhance your abilities, not use it to replace your abilities. Think of it
Yeah.
like that.
Yeah.
That's the biggest thing. And don't get lazy, right? Use it, integrate it, but don't be lazy about doing it.
Yeah. One of the very fascinating things that I found about your background was sort of that you worked with Larry Page and sort of advised him. You kind of mentioned that a little bit. I think at that
I work
level,
with the
yeah,
family office. I worked with
family
his family
office, yeah,
office. So, right. So
yes,
I work with the family.
yeah. So what does that process look like? How do you get to that level? What are the sort of conversations you're having? Because that's so fascinating, right? Like the company in the world at a certain point, Google, right, or amongst the biggest.
Well,
What sort of
I mean,
conversations you're having at that level?
I'm a scientist, right? I
Yeah,
was a very, I mean, as I said, two of my group mates have Nobel Prizes.
yeah,
I was a top scientist in my youth, so I just know them, and they asked me to. I just know them personally, and they asked me to
yeah,
help them with the project they were working on. I just started doing that. So that. I mean, that's like with any kind of thing. If you know people and they know you're
yeah,
good at something, they'll ask you to help them. And I helped them out for a while. I'm not doing that right now, but I mean, they were working on these problems. They have some investments that they're doing, and they just need. He needed someone who had a particular experience in nuclear physics and quantum computing and some of these things. And a lot of it came up during the pandemic because they wanted to make some help with during the pandemic with some, just trying to find some way to move the needle because obviously the whole world was shut down. Of course, I have a background in some of this stuff. So I was helping them during the pandemic in a philanthropic way and then help with some of their investments, just reviewing it. But it's just a personal thing, right? Someone and it's just like someone asking you to help, can you help me move?
Yeah.
I'm moving my apartment. I need you to help me. You're a strong guy. Can you help me lift some boxes? It's the
Yeah.
same thing, right? You just happen to know them and you have a particular skill set and they ask you to help them with something. That's not there's no sales there, right? It just turned out that they were
Organic.
working on something that
Yeah.
I happened to have known. And I knew someone who knew them and we had talked about it. I go, yeah, I actually know quite about that. I do know quite a lot about nuclear fusion because I know the guys who invented the technology and I worked on it back then. So we're working on some of this stuff. Or you know something about translational medicine. Yes, because I have a classmate who started a company in translational medicine, doing AI for translational medicine. Oh, can you help us out? And that was the kind of conversation I did, knowing just general science and knowing people doing science. That's what's going on there. So there's no magic there. It's just, you're in any environment you're in, you're going to know someone who is more successful than you. And yeah, it's generally a good idea to try to help them out if they need help. You
Right.
know, everyone needs help with something. That's all.
Yeah. And is there any other topics that we haven't talked about, or anything, any other message about AI or ML you'd like to give to the audience? Any sort of future trends or anything like that that we haven't talked about?
Well, I mean, for me, I've got this open source project called Weight Watcher, and if you're interested in AI, you're training or fine tuning your own models, you can join us on Discord, learn about the project, and we try to, we have people who have joined the project who want to do science. So they're doing research in Grokking. The Grokking paper is actually done by a guy named Hari who just joined the channel and is very smart, was interested in it. And we did some research and we published these papers and it's got accepted to these great conferences. And if you want to do that, that opportunity is there. It's like any open source project, it's just a community of people who are
Yeah.
very interested in AI. And I encourage you to join. And you can go to weightwatcher.ai and you can join the channel and we can talk about what's going on.
Perfect. And I think that is a great way to end the conversation here. Well, thank you so much, Charles. I appreciate you coming and sharing your experiences and things like that. And so you mentioned the website already. Is there any sort of a website for your consulting company where the audience can find you?
Oh, just find me on LinkedIn.
Okay, LinkedIn.
Charles Martin 14 or calculationconsulting.com. That's an old website. I'm on LinkedIn, Charles Martin on LinkedIn. You can find me. I've got a gazillion followers. So I'm happy to help out if I can.
Sounds good. Well, thank you so much, Charles. I
All right.
appreciate your time and
Thank you,
we
Scott.
look forward to it. And thanks for sharing your expertise with it. Thanks,
It's my
everybody.
pleasure.
Yeah.
Good luck. I'll see
Yeah.
you.
Thank you so much.
All
All
right.
right. Talk to you soon. All right. Bye bye.
Goodbye.
Thanks for listening to the AI Growth Podcast. Subscribe for more real world AI insights from today's leading business minds.